What's going on YouTube? This is Just Crust here, and I'm back with another YouTube video. Today we're doing the second of hopefully more daily iterations of Today I Learned. Today I only had one class, and it was linear algebra, and we spent a good majority, or not a good majority, we spent about a third of today's class just talking about our exam that we um, took on Thursday, received our grades for on Saturday, which if you were paying attention in yesterday's video or during my live stream on Saturday, you will know that me, as well as most of my people in the class, failed. Excuse me. The average was failing. Like the average was failing, which was really bad. And she spent the first. She spent roughly the first third of the class just talking about that. Talking about some of the common mistakes, hoping to identify what we did wrong, how we could go about fixing it, and such like that. I personally, some of my issues. Well, first off, I ran out of time, so on the last question, I attempted 2 parts of it, and there was 5 parts to the last question, which was really bad. So I got a 3 out of 13, or a 3 out of 15 on that part of the question. And then on one of the questions, the first question actually, I got a 2 out of 12. This is where I just came from. I got 2 out of 12, and that was proofing. And basically, she said a lot of the issues, are a very big majority of the most common issue, lied in our proofing. Basically, for most people in that class, I presume there's a lot of people that are CS majors in there, as well as some math majors like me. But in general, linear is taken early enough in every math circuit, and again, in general, in the comp sci circuit, where proofing is either not required or not needed, or just something like um, it's not needed, not required, not taught. I have not taken any proofing classes yet. Uh, I knew it. I heard it. I have not taken any proofing classes. This is my first introduction to like real hard, not even hardcore. It really was not hardcore at all. Proofing though, this is my first like real introduction to it, and it went about as well as you'd think it would. um, I just didn't. The big issue that I had, I was kind of, is this lapis or diamond? I was stuck conceptually on proofing. Conceptually, instead of trying to prove what was given to me or disprove it due to it not following one of the rules, I immediately tried to think of a counterexample instead, which is the wrong way to go. You need to think about the laws that, or the rules that you need to prove or to prove with a certain thing. So, like for example, we were given a set, and the set was an element of 4x4 matrices in all reals, for example. I heard another creeper. The set was like the set V gave us a matrix A that was in 4x4 reals. So there you go. There's your set. There's your subset. That's what we're trying to look at. And it said basically that that subset was the matrix A plus the matrix A transposed equals 0. And how could we go about proving if that was a vector space? Well, a vector space has 4 rules to prove. One is, or well, 3 particularly, but the method we used to prove it was a vector space was to first off prove that V was a subspace of the 4x4 matrices in all reals. So that's the first. Whoa, terrifying. And this is just a really weird little nook. Cool. Anyway, and so after we identified that the matrix A that was in RV is indeed an element, we had to prove that basically that the 0 of M, the 0 of a 4x4 matrix was inside of our set, which it was. We had to prove yes or no that given two matrices, the sum of those two matrices, given two matrices that are both in V, our big set, or our set, we need to prove that the sum of those is also in the set, which sometimes it's not. And then we have to prove that given K, that it is any real number K, times our matrix A, that is an element of the set V, multiplied together, that would still give you a product that is in the set V. I immediately jumped to trying to disprove the actual thing, the actual part of the set itself. Like, I just try to disprove, like, A plus A transpose equals 0, rather than trying to disprove that it was a subset and to try to show why I didn't want, or it wasn't a vector space. Or rather, I try to show why A plus A transpose equals 0 was wrong, rather than trying to prove that it wasn't a vector space. And it was weird, and I didn't get any point. I got like 2 out of 12 points on it. Like, it was really bad. And that was a lot of people's problems, was truth proofing. So kind of the math, I have a decent amount of the, what the hell? I have a decent amount of math down. Like, I need to like look more over null space and try to find surjectivity, because I can get injectivity pretty decently, knowing that things are injective if the null space is 0. Then we spent the rest of the class talking about like basis, and that's basically saying that you have a set inside of a vector space, and that set is the basis of that vector space, given that the set is, I think it's linearly independent, and that the span of the set is a subset of vector, or subset, or is equal to the vector space. One of those two. And it was fine. Some of the examples that we got were pretty simple, I would say. And then I will say we talked about basis for a little bit, and then we moved on to the basis of other things we learned. So instead of just looking at the basis of a matrix, we looked at the basis, or a basis of just a normal given vector space. We looked at special cases of special basis, such as the basis of the column space, and the basis of the row space, and the basis of the null space. And specifically looking at the dimensions of those, and specifically how there are special names for, oh, my shield broke? Whack. That means it might be time to go back, honestly. I don't even have any wood to make a new shield. Basically how the dimension of the column space has a special name called rank, and how the dimension of the null space has a special name called nullity, and how together they are two halves of the same whole called the rank nullity theorem, and how basically the rank nullity theorem says the dimension of the column space, which is looking at the basis, or the basis of the column space plus the basis of the null space is equal to the number of columns within or in that matrix. And the reason why is basically that the basis of the column space, excuse me, the basis of the column space is looking at how many columns, or looking at the columns in the vector, or no, in the matrix. I'm looking at how many columns in the matrix are non-free variables. Basically, it's looking at what is this? Oh, calcite. Never mind. Give that back. It's basically looking to see how many of the columns are non-free variables. How many of the columns are actually specifically leading terms. So like if you have, for example, your matrix in row echelon form, whichever columns have the leading terms, that's your basis of the column space. And then the nullity is the complete opposite. It's looking at how many columns within the entire matrix are free variables. So every column that's not a leading term is part of your nullity. And when you add nullity and your rank, you get the total number of columns within a matrix. And that's all we really talked about today. I recorded this video a little bit earlier, but it also took like 25 minutes to explain things because I was just really bad at it, and also I just did not know what I was saying half the time. I also forgot to put that disclaimer, but also you should probably assume, oh, there goes the bat. And there are some diamonds, nice, and a little addition to my collection. Basically, I'm not a master. I do not have a degree in anything I'm talking about, so please do not act like I'm teaching you. Do not act like I'm trying to actively inform you kind of about the things I'm learning. However, I'm not an expert on anything I'm learning, and I do not even know half the time if what I'm saying is completely half right, half wrong, or completely wrong. I don't completely know. I am only using this as a way to help myself remember what I learned. And the flip side of that is it's what I think I learned, not what I did learn. So if I understood something wrong in class, that's going to reflect in these videos, is that I just didn't understand it well. And so on and so forth. I didn't understand it well, and so I'm saying it wrong here. So just know that I might not be completely accurate 100% of the time. And that it sucks because I hope to be, because I hope to be understanding everything in my class. But if I don't, please don't bitch at me. I'm trying to learn. I'm trying to learn my stuff. But yeah, I think that's about it for today. This was a short today I learned because I only had one class. I went to office hours and I talked a lot about the stuff I described earlier with my exams. So even if I didn't go to office hours, it would have been even shorter because I wouldn't even know what I did wrong half the time. Tomorrow will probably be a much longer video because I have 3 classes to talk about, because I'll be watching my Monday lecture of the New Testament class. I think it's about the Acts of John. And then we'll be discussing probably the 1860 election in the nether class, in the next class, or in the Civil War class. We're gonna throw away the furnaces. I can live without furnaces because I can have enough stone. Yeah. So basically, that's about it. Thanks. Let me get into a little corner. Thanks so much for watching, and I will catch you all next time, probably and hopefully tomorrow.